classmate who registered for this internship but hasn't joined yet, this is a perfect time to give them a quick call or send them a reminder message. Tell them to join immediately because this is our last masterclass and we do not want anyone to miss such an important session. Okay, now let's make today's session the most energetic one. I want to see you all giving a thumbs up who all are really excited and enthusiastic to learn about the project, and I am also looking forward to see futuristic projects from you all. Who all agree with me? Please give me a thumbs up. Great. That's the energy we love to see. So let's quickly get into today's agenda. Over the past few weeks, we have learned about introduction to the course, foundations of agentic AI, it workflows, how LLMs worked. We learned about complex AI agents, building a tracker. Yesterday we discussed about project discussion and lean canvas. So in today's session, our technical trainer would be addressing on AI agents using code and line graphs. So this is very important for you to attend. So I request you all to be attentive throughout the session and be in the session till the end. So again, I'm iterating, complete your learning plan. If you haven't started yet, we are giving you a final chance. Start it, complete it, and submit the required certificate. We have sorted all the queries that we received with respect to offer letter as well as dashboard. Still, if you have any queries once the chat is open, or else tomorrow we have a dedicated session for non-technical queries, you can join that session and get your queries being addressed. I iterate again. Tomorrow we have a dedicated session for question and answers on non-technical queries with respect to dashboard issues, or if you haven't received your offer letters or any other issues, you can draw or you can connect with us tomorrow. We have a session from 4 to 6. You can join it and we will be addressing each of your queries. So yesterday also, after our technical session, our team sat with you all and we have addressed most of the queries, and we received some queries in the WhatsApp also, which some of our teammates have addressed it. If your query is not yet addressed, you can send me the details in WhatsApp. I'll try to address it. Fine. Okay. Now it gives me immense pleasure to introduce our speaker for today's session. We are delighted to welcome Mr. Amit Tiwari. Everyone, let's welcome Mr. Amit Tiwari with a virtual thumbs up. So over to you, sir.
All right. Thank you so much, Nandini. Okay, so welcome to the final masterclass. If we are able to complete everything today, otherwise, one more masterclass after that. Um, what we are going to do today is we are going to build our agents with code, and I'm excited for this master. So we'll be using Google Colab in this. I hope that you already have that. I'm not using VS Code to code because not everyone will have the libraries installed, and not everyone is also used to use VS Code, but we can always use VS Code whenever required. So whoever is using VS Code, they can freely use VS Code, but I'll be using Google Colab in this class. So let's start our session today. I'm going to share my screen. And okay, so a quick recap of what we have done so far. So we have started with our agentic AI journey by building an AI agent itself, where we said that in any workflow, if we can replace a large language model, if we can replace a human brain with a large language model, we'll be building an AI agent. So we built a AI agent that can automatically email people on our behalf using relay, which was drag and drop. So what we did was we made a workflow which starts from uh, opening the Gmail, then reading the email, understanding the email, writing a reply, and sending the reply. In those process, the three processes, reading, understanding, and writing, we gave this task to large language model. So we replaced wherever we needed our brain with a large language model in the process, and we were able to build our AI agents in this process. So today what we are going to talk about is, let's say if we build an AI agent with large language model, then what happens is AI agent is a system whose control flow is defined by a large language model, right? So let's say that I want the large language model to make a decision whether to follow step 2 or whether to follow step 3. So let's say that I want to make a AI agent for my email system, but I also want it to not reply to any spam. So I will make a classifier for large language model. If it's a scam, if it's a spam, then it will not reply. If it's a professional email, then it will reply. So I can control the flow of my workflow with a large language model. So this is what an agent is. So agents have a agent has different steps, which we call as nodes, and a large language model is one node which defines what task the agent will do. In our task tracker, which we designed last time, we also were able to email people with the task tracker, those who have not completed their task, right? So we were also making multi-agentic system. Now, the problem with drag and drop is there are two kinds of agents that we want to design. One is a router-based agent, in which a large language model decides which path to be taken. So if I talk about my first agent which we designed, the email agent, we will design a router which will first understand which kind of email it is. And after that, it will take the route or take the route of, after classifying. If it is a professional email, it will reply professionally. If it's a personal email, it will reply personally. If it will send it to my WhatsApp. If it's a email which is a spam, it will delete that, right? So a router will decide which way the agent will go. In this type of agent, the router has less control, the LLM has less control over this agent, and we design the flow. So a router based agent, a large language model or AI has less control over it, and we define where the agent will go after each step. Even classified by LLM, we define the steps that the LLM will follow, right? And then there are fully autonomous agents. These fully autonomous agents have a brain, which is a large language model or any AI system, and that AI system defines what steps should this agent follow. Okay, so we do not define the predefined steps, the AI only decides that. So the control of AI in this kind of system is more, which are fully autonomous. Now we always want to move from a router based system to a fully autonomous one. But the dangers are that the AI will only decide what to do, right? AI will only decide whether to reply or not. AI will only decide whether to classify that as spam or not, delete that or not. AI will only define whether to send me a WhatsApp message or not. The problem with this is that AI does not know about how I work, right? So either I will have to tell everything to AI about my working system, my prompt will become really huge, and this system will also be slow. A router based system is fast because I know what my steps in my workflow are, and I don't have to do one shot prompting in this. So I define the steps, but the control with AI is less, and I have to, if I have to like change any step, if I want AI to behave in certain way, I have to change the step manually. Okay, so there are two types of agents. One is a router-based agent in which we define the flow. LLM only routes, right? So LLM classifies, and then we define whatever the task that the LLM will do. And then there are fully autonomous agents where LLM or the AI only decides what to do next, right? So it decides what to do next and it decides where to go. Okay, now there is one major challenge with router based and autonomous agents. and this is a graph of reliability versus control. So how reliable will my agent be given that the AI has more control? If AI has more control over the agent, the agent will be less reliable. Okay, if the control is high, then reliability is less. Why? Because I don't know what AI will do to my workflow, because I have given everything, all of the control to AI, right? So if I give more control to AI, my agent will be less reliable. If I give less control to AI and I only define what route to follow, then my reliability is higher, but my control by AI is low. So I am kind of like designing these AI agents, which I will have to change manually. Autonomous agents, they behave automatically and we don't have to like change them manually. Router based agents, if I need to make any change, I will have to change it manually for any change in the process. Okay, so the problem with this is that if I give AI more control, reliability is less. So how can I make this AI agent more reliable given that the control to the AI is high? That means that I give more control to AI to make the agents, and in the process I also improve reliability. All right. This is what the problem is. So how can I be in a sweet spot where reliability is also high and control to the AI is also high, right? So this kind of sweet spot is given by Lang graphs, and that's why we use Lang graphs to design agents professionally. So Lang graph is one framework to design AI agents, which is designed by MIT students, and it's free to use by anyone. What Lang graph does is that the AI has higher control of the flow, but we also in the Lang graph, what it does is that it also gives reliability to the flow. Okay, so the reliability is also higher and the control of the AI is also high. So we are not creating like autonomous agents where reliability is low, but Lang graph gives us that framework that we can design AI agents where AI can control most of the flow, given that the reliability also stays high. Okay, so this is where Lang graphs are very, very good. And in the industry, Lang graphs are used extensively. Now let's discuss about problems with plain agents. We can make AI agents with drag and drop, and we have been making it till now. So one is that the AI agents that we make with drag and drop is it has one shot reasoning, right? Like in N8, maybe we can even give more context, but and examples. Uh, but still we are it's kind of like we are doing every task in one shot. So we are giving all of the context to AI in one shot, and AI is doing some task, right? So AI is not learning from its mistakes, or there is no looping control, right? Second problem with drag and drop is they are hard to debug because we don't know how the node is created, right? We know that there is a node, but we don't know the code behind the node. So we treat the node as a black box. Let's say that we drag and drop a AI agent in N8, but we don't know how that AI agent is being designed, right? So we treat it as a perfect AI agent, and that's where like if there is any problem coming inside the code, it's hard to debug because we have not written the code here. There is no state memory in plain agents, and there is no control over loops. So although like in N8 we can make loops, but they are harder to build. So here comes in LangGraphs. So LangGraphs have these properties. LangGraph is a library of Python, which is designed by MIT students. So we import this library and we can build our graph using LangGraphs, which the same kind of graph that we are building with N8 and other tools with nodes and branches, we will be able to build with LangGraph. So why LangGraph is that first, it has a memory. It keeps track of information across each step. So LangGraphs have a state memory which tracks each information across steps. Okay, so there is a shared memory which goes into all these steps. Okay. And there are loops. So LangGraph also supports loops. So anytime if a step fails, so let's say that the email is not sent, I can go back to my step one and retry. Okay, so LangGraph has like inbuilt looping capability where anytime if my um, if a step is failed, we can always go back into the previous step. Line graphs also give us flexibility. That means that we can choose different path based on model outputs, and it gives us more better control. So whenever as a company, like my company makes AI agents for businesses. So when we make AI agents for businesses, we prefer line graphs because we get more control over the agents that we are building. We build with n8n only when we have like a small project, or when we have components that we will not be able to build, like let's say that if I am building something for Instagram and there is already uh, permissions being taken by n8n to take in the API of Instagram, then I will be using n8n in that case. But for more security purpose as well as more robust stability purpose, I always use langgraphs with Python so that the system stays inside the business premises. So there are lots of business owners who don't want their data to be shared with a third party. So we use langgraphs to build in their premise um, the systems in their premise so that the data doesn't go anywhere. So there is more control, there is more flexibility, more looping system, more memory. So langgraphs have some things similar to what Node, n8n, and Relay have. So every function in langgraph, every function that we make is a node. Edge is a AI. We add AI to the edge, which decides whether to go to node 2 or whether to go back to node 1 or whether to go to node 3. So AI becomes a edge or a deciding mechanism. And then there is an end. So each graph in line graph has a start and an end. And then we deal with nodes. So nodes are like functions which pass on information from one function to other function. So let's say that if I want to open Gmail, then opening Gmail would be my one node. Getting data from Gmail, opening my Gmail and getting data from Gmail would be my one node. AI will be the edge which will write the email, and node 2 will be going back to my email and Gmail and sending the email, right? So this is how line graphs function. So it has a start, it has nodes, it has edges where we add AI, and it has an end. So there are some key concepts that are required in order to make our own line graphs. First one is node. Node is any step or function in the flow. So let's say that if I want to summarize text anywhere in my flow, that will be a node, right? So then there is an edge. Edge is a connection from one node to other. And we can add in AI in between. So we can make a conditional edge, whether or not to go to one node or whether to go back to the node itself. There is a state which is a shared memory across steps. So there is a state, that means a memory which every node can access to. Okay, so every node can access to this memory in which we can store any information. Events are called triggers for moving to the next node. So if we want to move from one node to next node, they are called events. So these four terminologies we need in order to understand line graphs. So there is node, which is a step or a function in a flow. Edge, connection from one node to other. Graph state is one memory which is shared across all these nodes. And there are events which we can trigger, which are triggers from moving from one node to next node. All right. Previous to line graphs, there was LangChain. And LangChain was the technology that was used to build agents. But LangChain was linear. That means that there was a linear flow. So we only go in a kind of like a chained flow in LangChains. We move to LangGraphs, which is kind of like more of a node flow. So if you see here, there is a chain flow and there is a graph flow where we can move in a graph. But in chain flow, we can only move in one direction, right? So that's why LangChains are basic. Loops are not easy in LangChain. They are limited and they are best for simple chains. So let's say that I give input to a LLM and get the output out of that LLM. That's the only task that I have to do. I will use LangChain. For LangGraph, I can build any complicated agent for that matter. All right, so the problem that we are going to solve today and the sample LangGraph that we will build is for a hospital. Okay, so the problem to solve is many organizations, they receive high volume of repetitive but high risk request, right? So in many businesses, they have repetitive tasks, but they are also high risk. Like let's say customer emails, internal tickets, policy questions, operational queries, there can be many tasks like these. While these tasks, they look simple, they fail when they are handled by basic AI, okay? So what goes wrong in this is that, first of all, one short answers are unsafe. AI can hallucinate. So most AI systems, they respond in one single step, just like ChatGPT. So there is no planning, there is no verification, there is no accountability. So these systems, they kind of like fail in when they come to actual use case. So the result is we get wrong information, there is missing context, there is overconfident responses. Like my agent in my first agent, right? So when somebody sends me a personal email that will you come to a party on this Saturday, my agent will say yes, I will come to a party, because it doesn't know anything about me, whether or not my Saturday is free. So it doesn't have a context, right? So that goes wrong with simple agents. So the core business problem that we are solving in today's class is for hospitals. So I'm choosing SDG 3, which is good health and well-being. And there is one problem in hospital that I have seen a lot. So one is hospitals, they receive a lot of patients with varying symptoms, but traditional intake process rely on manual things, right? So let's say that I go to a hospital and I get to a receptionist and I tell that I am having fever. Then the receptionist will tell either for me to go to a certain doctor, right? But there are less receptionists. There is very less hospital staff in India according to how much population that we have. So hospitals are often overcrowded. There is a long queue in front of the receptionist just to get inside the hospital. So the nurse or the receptionist, they always uh, decide under time pressure because they have a long line, which department that they should go. And this creates several challenges. One is inconsistent routing. So let's say that they will send you to a ward and then they will ask you to wait in that ward. And after some time, somebody will come to that ward and take you to the doctor, right? So how about like, how can we go to the right doctor at the first step? Because these people also don't know, because they have a line to follow and line to kind of process. So they ask you to wait for some time. So there is a lot of waiting time, first of all. Second is bottleneck at peak hours. So manual intake doesn't scale when many patients arrive at once. So let's say in Corona, when there were like too many people going to the hospital at once, the hospital staff will not be able to manage these many people. Critical cases can be missed. So let's say that there are people who need immediate care, but they have to like stand in a line for like 20 minutes or 30 minutes or so. How can we make sure that this case also not be missed? How can we use AI in order to do that? Okay, and because there is no structured auditable decision trail, it's hard to review why a patient was sent to a particular ward. Okay, so this is one problem. So the problem is that there are very less receptionists in hospitals because of the shortage of the staff. Also in remote areas like the village that I belong to, there is only one hospital, there is only one receptionist, and often I have seen a huge line in front of that receptionist just to get inside the hospital. How silly is that? So how can we solve that problem with AI is what we are going to learn in today's class, and that we will do with code. So what I'm trying to make um, is a hospital agent whose flow looks like this. Okay, it's a simple agent that we are designing today, but we can make much complicated agents with code with LangGraph. Okay, so we are designing a system, agent that has a start, and there is an intake. It's kind of like a screen in hospital where a patient will have to fill in some information like its name, its age, and what is they suffering from. So I am trying to build a kiosk screen in hospital. Instead of a receptionist, we can go to the kiosk, tell the kiosk our name, our age, and our query, what are we suffering from. AI will be our receptionist. Okay, so AI will decide if I am having an emergency, if I have, let's say, accident, then I will go to the emergency ward. If I am having general problems, so let's say that I am having fever, I go to a general ward. And if I am having something like depression, I go to a mental ward, right? So AI is identifying which ward do I have to go to, and AI is also checking which doctor is free at what point of time. So I'm talking to a AI, and AI is checking which doctor is free and routing me to that particular doctor in the process. Okay, so let's say that there is a hospital data in which there is doctor information, and it also tells which doctor is free at what point of time. So AI not only routes me to the particular ward, but also routes me to the doctor. It can send a message to the doctor that this patient is coming to check up. It can also tell you that this doctor is where we have to go. In your map, it can also give you a direction. When you click on the map, you can go to the doctor using AI, right? So this is a kind of like a very nice way of handling more patients in uh, in a hospital setup rather than having a single receptionist, which is having flood of patients are waiting in a line. So instead of that, we can have a kiosk screen where everyone is telling their query to uh, AI is deciding which ward to go to, also checking which doctor is free. If the doctor is free, it is also fixing the appointment for that person. Okay, and this we will build with code. So all of this that we have will build everything with code using LangGraphs. Okay, so the real problem with any type of AI system is not automation, it's always reliability. How can we build AI systems that can think, act, check, and correct themselves before impacting the business, right? So how can we ensure that they are always reliable, they are always giving us the right results and not the wrong ones? So let's talk about that, and let's build our hospital agent with code today. Okay. Sal is saying we can also ask for patient phone number to guide him or something like that, all done by the AI. Yes, we can also ask for the phone number. We can send him the information, where to go. We can also guide with the map. Okay. All right. So let's build. To build it up, what we will do is we'll go to our open a browser, and there in your drive, go to Google Colab. Okay. So type in Colab, and here open a Google Colab and make a new notebook. Okay, so I already have made it. I'll make a new one. Go to file and make a new notebook in Drive. I'll do it with my official one. So I go to Google Colab, and in Google Colab, I will go to file and make a new notebook in Drive. Okay, so those who are doing with Google Colab, they can do it with Google Colab. Those who want to do with VS Code, they can also do it with VS Code. Okay. All right, so this Google Colab file, we will rename as hospital agent, and we'll be building it with Python code. Okay. So those who have made a collab new notebook, just say done or yes in the chat, and then we will start coding here. Okay. Thank you so much, Tanvir, Krish, Fatima, Sahil, Urmi. Okay. So we have to do this thing. We have to go to Google Colab and make a new notebook. and just say done once you are done with the new notebook. So you have to make a hospital agent new notebook, okay, in your collab. So we'll be coding one by one. So first code block, I'm deleting this one and I'm adding a text block here. So this will be to install required libraries. Okay. So what I will do is I will write the code one by one and I'll be sharing that code to you on the group chat, as well as I will be sharing that code to Nandini to be sent in the group. Okay, so we'll be writing one by one and I will be sending this code one by one to you so that you don't have to like type in everything. You are just copying and pasting and understanding the code. Okay, so the idea is not to write the whole code here, but to understand how the code is, because of course we will be generating code with AI, and there is no doubt about it. AI can write far better code than us, but we need to debug it and we need to learn what it is doing in the process. That's all that we will do. Okay, so what I will do is I will share the code with Nandini as well as with you. Okay, so first thing that we have to do is we have to install LangGraphs and pandas. Okay, so where is it? Code and you install LangGraph, Grok, pandas. So one API that we are using in today's class is Grok API. So the AI that we will use in this class is from Grok, Grok. So this is also what you will have to do before writing code, is that you will have to go to Grok. Okay, you will have to get the API from there. Grok. Okay, type in Grok in your browser before writing the code, because this is the AI that we will need. So Grok offers you free APIs. Okay, so you can use Grok APIs to use as AI, because you will have to use something like OpenAI, right? Or Google Gemini or any other API with your agents, because you need the AI brain. So what Grok does is that it offers you free API. So you go to developers here and click on free API key. Okay. So go to Grok, go to developers and click on free API key. You will have to log into Grok for that. Free API key and click on create API key, and you will get the API. Rename your API key. So let's say that medical bot API. And once you press submit, you will see your API key here. Okay. Now I am stopping the screen share for some time so that I don't give my API key away. So I am putting this to PPT, and in the back end, what I will do is I will submit the display name, and there I will get the API. I will have to just, once I get the API, I will just have to copy that one. Okay. So keep that browser tab open. Okay. So Maha is asking what is an API. So API is application programmable interface. So any software has only three parts. Let me explain it here. So any software has only three parts. There is a front end, there is a back end, and there is a database. Okay. Now, if I need to talk from front end to back end, okay. So a very good analogy that I give is, let's say that you want to eat something and you go to a restaurant, right? So the menu of the restaurant becomes your front end. So let's say that I want to eat dosa. Then I go to a restaurant and I order a dosa. So I don't go to the chef directly, right? So I look at the menu and I don't go to the chef directly like backend. I don't go to backend and say that make me a dosa, right? That doesn't happen because that system where I go like from a single point of contact system, like you, a customer goes to the chef, there will be lots of people, those who will flood the kitchen, and then there will be chaos, right? So what I do is I call a waiter. So that waiter is a API, that is my application programmable interface. That means that it will take my order, it will take my payload, whatever I will give information to that waiter. So it will ask me what type of dosa do I want? Do I want it crispy? Do I want it in oil or butter? Whatever information that it will get, it will take that to backend. Backend will process the request and it will send the order again with the waiter to you. So API basically is that waiter. So this allows you to build apps for various platforms. So you can have like one backend where everything is happening, and you can build a Android app, you can build a iOS app, you can build a web app, and you can build a kiosk screen, all accessing this backend through API. So anyone can access this backend through API, those who have the API keys, and they can use the process that is happening in the backend with their app, right? So ChatGPT has designed its own ChatGPT LLM. So it so we can use ChatGPT's backend by our apps if we have the API keys to ChatGPTs, if we have the access to the backend, right? So how a restaurant also gives um, orders to Zomato is because Zomato is giving the order to the restaurant. In the restaurant, the chef is preparing the food and then giving you the food, right? So Zomato is using that interface in order to provide a food to a person who is far away. So a person can access the kitchen of any restaurant through three different ways now. One, by going to the restaurant, which is by ordering to the waiter. Second is ordering by Zomato, which is again like we'll go to the waiter and waiter will tell to the cook that this is what to be cooked. And then like with Swiggy or any other app, right? So that's the analogy that I will give, that anyone can access the backend through any of the app if we have the API of that. So if we need to use AI, we cannot use AI just like that. We will need the access of that person or of that tools backend, and that we will do with API. Okay. Now, so you create a API key and you copy that up. And once you're done, please paste done in the chat box. So you have to go to Grok, GROQ. You have to go to developers. You have to click free API key. You have to make your API key, and you will see a API key that you can just copy up. Okay. So once you copy, and in your LangGraph, now let's come back to code, which we were doing. Where, okay, not here. Okay. Uh, hospital agent. All right. So once the first step is to install the required libraries. And after installing the libraries, what we will do is, okay, so after installing the libraries, what we will do is we will import the API key. Okay, so this is the code that I have written, and I will make sure that I will teach this like one by one. So after installing the library, we will import the API key. So import the API key, go back to your code, and add in a text. So I'm saying that I need to now import the API key, shift plus enter. What I'm using to import the API key is, okay, people are asking me to repeat the grok part. Okay, so in this, there will be an error, which is fine. You just need to ignore that. Okay, so what we are doing in the first step is we are installing quietly. QU is for quietly. LangGraph. LangGraph is a library. We need LangChain. LangChain dash grok in order to use grok because we are using grok's API and pandas. Pandas for data processing. But don't worry, this pandas will only give you error, which is fine because it will not be incompatible. It is incompatible, but that's fine because we already will have pandas 3.03, right? So it is saying that it requires pandas 2.2.2, but we are installing 3.03, but that's fine. We are not installing that. So it will not install pandas 2.3.0.3, which is fine. Okay, so this error doesn't mean anything. It is fine. Second is we will import the API key. And to import the API key, what we will do is we will use this code and there it is. Okay, so we will import OS. What it will do is it will let me use the OS. I am importing get pass, which will make my key not visible. Okay, so I'm copying the code from here and pasting it on the group so that you can access it from there. So I am importing OS, and from get pass, I'm importing get pass, which will make my key not visible to anyone. Okay, so when I paste my key here, it says enter your grok API key. When I paste my grok API key in the as an environment variable, so when I make this app live, I need to not do not share keys, API keys with anyone. Okay. So the best practice is not to share, API keys with anyone. I have some issues with my keyboard and Zoom. So it always like goes away. So I am here making an environment variable, which is grok API key. So you will only see my grok API key as variable. And here I enter my grok API key. If I run this, you can also use collab secrets. This is like whatever you want to use. I am making it more simpler. Generally, what you need to do is you make a .env file, and from there you import .env, and from there you import it. Okay, so generally in a software development, you don't um, put in API keys directly. You make a .env file, and then you make environment variables, and then use them in code. Okay, so once I do this, it will ask for my grok API key, and I will paste my grok API key here, which again I will have to like pause my screen share because for copying. Okay, so I'm not exposing my API keys to anyone. And this is very, very important because you don't need to expose your API keys because anyone can use your API keys and spend your credits. Okay, so I'm copying my API keys, going and pasting, and I will share the screen now. Okay, so now you will see that I have these stars marked here. So if I press enter after this, I will have my API key. So this API key I will use in my code in order to make the agent. Okay, so whenever I need to use AI, I will use this API key. So import OS, that lets me use the operating system from where I'm making an environment variable, which is grok API key. I'm making an environment variable like grok API key. I'm using get pass to make my key not visible to anyone. You can also use secret keys from here. So you can add a new secret key and you can name it as Grok API key and you can use it from there as well. Okay, so you can also do that. But to make it simpler, I'm just using get pass for making it a password kind of thing. Okay, so I'm entering my Grok API key. Now, after importing the API key, what I will do next is I will import the data of doctors. Okay, so where is it? I will add a text box and I will import data of doctors. Why I'm doing this is because I need, so this data will be coming from the software that the hospital uses. Okay, so right now I'm using a CSV file which looks like this, doctors.csv. I will have to find it and I will also give it to you to copy and upload it to your drive. Okay, so I am sharing it in the group. Get the doctors.csv file from there. And if you're not able to download it from the group chat, I'm sharing it to Nandini as well so that she can share you in the group. Okay, so you will see there is a doctors.csv file in which there is a list of doctors that are there in the hospital. Okay, and if I share my screen, it looks like this. Okay, so it is like doctor name is Dr. Sharma, ward name is general, status is active, next slot is this time. Okay, so wherever the slot is. So the people, those who are not able to copy it from the chat, I'm also pasting the code in. I'm also copying and pasting the code to Nandini so that Nandini can share you in the group. Okay, so you can access it from the group now. And done. So okay, so we need to import data of doctors. For importing data of doctors, I will use pandas library. So I will make an instance of pandas library and I will import these. But for that, you will have to go to files and upload the doctors.csv here. Okay, so you have to upload the doctors.csv, which I have sent it to you. But not letting me even type in here. Okay. So upload doctors.csv. And search manually. Okay. All right. So doctors.csv, I just uploaded it to here. So this is how the file will look like if I double click on it. So it has doctor's name, doctor ward, status, next slot, and slot minutes. Okay. So where is the slots? So this is what I will upload. So what is the doctor's name? What is the ward? What is the status of the doctor? Next slot and slot minutes. So we have three wards: general ward, emergency ward, and mental health ward. And there are two doctors in each ward, and the status of that of those doctors. Okay, so whoever doctor is active and um, free. Okay. So we will import the data of doctors, and to do that, I'm now sharing the code that will make you import the data of doctors. Okay, so the code that we will write is this. So I am going to import from Google Colab files, and I'm going to import pandas as PD. And it will ask me to, so you don't need to like upload it here. So I have made a system where it will ask me to upload, which is fine. So I'm deleting this up from here. I just wanted to show you how the file looks like. I'm using a files thing for me to upload the doctor's file, to upload the doc doctor's file. And I'm importing pandas as PD. Pandas is a library that can use for database. And I am creating uploaded, which is files.upload. So I'm whatever file I upload, that will go to uploaded. And doctors underscore df is I am reading this CSV file, which is doctors.csv. I have shared it with you. And this is doctors underscore df for data frame, right? So what I'm doing is I am going to use this files.upload folder, which will let me upload a file in here. So if I run this up, I'm sharing this one with Nandini as well. Right? So I'm importing files from Google Colab and I'm importing pandas as PD. And if I type in this uploaded, which is files.upload, which will give me this option of selecting files. Okay, so I will select a file from here, which is doctors.pd. Okay, doctors.pd, which is doctors.csv. Right, so I will search for my file. You will have it in the downloads folder. Um, it's not making me search while I'm sharing the screen, so I'm stopping share for some time and searching for doctors.csv. I don't know why I use Mac for Zoom. It's not a good. Uh, it doesn't allow a lot of things to do while sharing the screen. Okay, so once I choose doctors.csv, so you choose a file doctors.csv, it will look like this. So these are the doctors and these are active. These are the next slot and slot minutes. So it has ward name, status, next slot minutes, when that doctor will be free. Okay. So you will also have to do this. Choose files, go to your downloads folder, upload it there, and you will be ready. All right, so I will wait here for people to catch up with me. If you have done, then say yes or done in the chat box. There are a lot of people who are just talking about their um, queries, about their learning plans and certificates. We can do that later, guys. I mean, right now, let's use the chatbot for uh, this query. This is kind of like distracting me a lot. So if you have any query, we will take it up by the end of this class regarding the activities and the certificates. Um, so please refrain from asking it here. All right. So thank you so much for saying done, that we have now the files ready. So we need this context of doctors, right? So we need which doctor is free at what point of time. Okay. After the doctor's file, what we will do is we will create a shared memory, which we will call as type tick. I told you that I create a shared memory. Okay, so land graphs have one shared memory, which it shares across all the states. So one person is a problem, which is, yeah, you will have to run that one. Yeah, so once you run it, you will see a upload folder from here. You will click on that file, upload the file here, and it will be uploaded and you will see the doctor list. Okay, so now we need to create a shared memory. So Pankaj is asking me to repeat. Uh, okay, so you install the libraries by this, import the API key, put in your API key from Grok, get the API key from Grok, and then you import data of doctors. So you are using this Panda library and read CSV function to import the CSV of doctors, which I have given to you. Nandini must have shared you in the group. Okay. So now we need to create shared memory, which is one memory that every node in this graph will share, and it will be a type dictionary. Okay, so let me quickly close everything. Just give me 1 minute, guys. I just need to close everything that is there in my PC so that it doesn't get hang. Just the relevant things. Okay, now I'm ready. So you need to make a type dictionary, which is a shared memory. So this shared memory is a type dictionary. So you use this dictionary to be shared across all the nodes. Okay, so whatever we need in this agent, we will make that variable here. So we need name of the patient. So we will make one variable name which has a data type string. We need age of a patient, so we make one variable age, which has again a data type string. We make query, which is the patient's query about the disease. We make that. We need that as well. We need ward, which ward to go to, right? Mental health, general ward, or um, general ward, mental health ward, and the emergency ward. So that also I am making a string. Reasoning, that means that why the AI has sent some person to something ward and who is the assigned doctor. So whatever memory that I need, whatever input or output that I get in this agent, I will make it a dictionary in which I will store all of these variables. Okay, so I will make a class patient state which will inherit type dictionary, and this type dictionary I'm importing from typing. I'm importing type dictionary in literal. So literal means that if I have some constant, then I can type in that constant as well. So name is string. Age, again, I'm storing it as string. Why string in age? Because people can write age in words, right? So let's say example, I write 32, right? So I can write 32 like this, I can write 32 like this, whatever, right? So that's why I'm taking a string here. So you import typing, you import type dictionary and literal, and you make a class patient state, and you use a type dictionary where you take in name, age, query, ward, reasoning, assign doctor. So I'm giving this code to Nandini as well so that she can share it with you. Now, if I use this, if I run this code, then a shared memory will be made, which will store every variable that I require in this whole graph. Okay. Now, after a shared memory, so I told that one problem with our drag and drop agents is that it doesn't have a memory, right? Now I have a memory here, which I can use in each and every node that I have. Okay. So once we have the shared memory, we will take the intake node. So first node we will create, which will be our intake node. Okay, so I will create an intake node. So intake node is nothing, but it is taking in the input from the patient. Okay, so this will be my first node in the process. After I create a type dictionary, which is name, age, query, word, reasoning, I create an intake node. So this intake node, what it does is that it takes in input from any patient. Okay, so I'm defining this intake node, which is inheriting this state. So now every node will inherit this state, which is patient state. Okay, so every node will have the access to this memory in which I can store or delete. Okay, I can access or store. Okay, so it is pointing to patient state, which is the memory here. Now I will print that this is the intake form. Name is input. I will take the patient name. Age, I am using this input class to take the patient age. Query, I am using this input class to take the patient symptom. And I am returning these three things. Name, age, query, word, reasoning, and assigned doctor will be null, 0, because this output will be defined by next node, right? Okay, so I will share the screen one more time so that you can um, see the graph which we are building. So we are building this graph. So my first node is an intake node. It can be a form. or my kiosk screen output. But right now I'm using the input class from Python to make it simpler. Okay, so I'm asking patient name, I'm asking patient age, and I'm asking patient query. Okay, so only three things. What is the name, what is the age, and what is the query? And after that, I'm giving it to AI. So this is taking in, this is my front end basically, where I'm asking name, age, and query of the patient. Okay, so I'm designing this node. So this node takes in name, and I'm using input class to take in patient name, age, input class to take in patient age, query, input class to take in the query, and it returns, this function returns name, whatever name is there, it will store that in the name in this patient state here. Age, whatever be the age of the person, it will store here. Query, it will be storing here. Okay. So this is nothing but just taking the name, age, and the query of the patient. So we made our first node, which is the intake node. So I told you that every node will be a function which will be inheriting this memory, right? So every node is a function, like intake node is a function. I'm defining that function, and that will inherit this state, which it inherits from the previous state, okay? Which inherits from this memory. So we have created a state, which is a type dictionary, which has all these variables. So this function will have access to all of these variables. And after taking in input name, age, and query, it now changes these variables. So now I have in my memory the name of the patient, the age of the patient, and what is the patient suffering from, which I will use in my later nodes. Okay. So we create an intake node first. Then after creating an intake node, we create the agent router node. Okay. So we'll create the agent router node, and this one will be a bigger one. So after intake node, it will be a router node. It will be an AI that will decide on the base of the symptom of a person whether to send him to an emergency node or general node or mental health node. Okay, so the AI is being implemented at this node. Okay, so I will add in the router node, and this will be a bigger node because here I will decide the prompt also. Okay, so from langchain.grok, I am importing this chat grok. So this will enable me to chat with grok. From LangChain core messages, I'm importing system message and human message. System message is the prompt that you give to the system, and human message is whatever the human is giving, right? So let's say that in our case, system message will become like this, that you are a hospital agent router based on patient description, classify them into exactly one of these wards. ये मेरा system message हो जाएगा, and human message will be whatever the patient query will be there, right? So the query of the patient will be the human message, and system message will be what I want the system to behave like. Okay, so I'm copying this code and pasting to Nandini to paste it in the group, and I'm explaining this code one by one. So I am making a router node. I am importing from langgraph, langchain underscore grok. I'm importing chat grok, which will enable me. Okay, this will enable me to chat with grok API. Okay, so we used Grok API, and this will enable me to chat with Grok API. Here, system message is the system prompt, and human message is human input. Okay, is human input. Okay, so system message will be whatever prompt that I give to this to behave like. So I'm using the LLM. Now we will make a LLM class which will take in chat grok as a API. It will take in the model of Llama 3.3 70 billion model, and temperature is 0. Okay, why temperature is 0? I will explain in a bit. Okay, so temperature in a large language model is used to make the LLM more creative or less creative. Okay, so if there is more temperature, LLM is more creative. It can write poems, it can write a mess, it can write essays, it can write emails. And okay, intake node code is not received. So I am sending it again to Nandini. Nandini, can you share the intake node code with students? I think that you missed sharing the intake node code. Okay, I already have shared it with you. So if LLM is more creative, if temperature is more, and LLM is less creative, more temperature. So if temperature is 1, then LLM is creative, and if temperature is less, LLM is less creative. So I don't want LLM to be creative in this, right? I only want LLM to classify. I want LLM to tell me which wards the patient have to go to. So I am making a router system prompt. You are a hospital router. Based on patient's description, classify them into exactly one of these wards. Okay, emergency. If it is a life-threatening or urgent physical condition like severe pain, bleeding, breathing difficulty, chest pain, accidents, high fever, unconsciousness, then make them go to emergency ward. Mental health, if psychological, emotional distress like anxiety, depression, panic attacks, suicidal thoughts, self harm, trauma, go to mental health ward. General ward, if anything else, right? Routine checkup, mild, chronic, non urgent symptoms like cold, minor aches, follow ups, etc., go to general ward. And respond with only one word: emergency, mental health, or general. So I want the AI to be only responded with one word and not be creative in this case. So it needs to be responding only emergency, mental health, or general. So I am making temperature 0 here. If I want it to be more creative, then I will make temperature 1. Okay. All right. So I'm using this model, Llama 3.370 billion parameter model, which is a free model from Meta. Okay. So I'm using that. Okay. Yes. Now I'm also using some hard safety net words. So I told that LLM should be reliable, right? So I'm adding in safety in here to make it more reliable. So these hard safety keywords, they will always override LLM. So if somebody says I have chest pain and LLM does not classify that into emergency, then that's a problem, right, for the hospital. So in a hospital, we need certain accuracy. So if someone has a chest pain, if someone can't breathe, if someone is unconscious, if someone has a severe bleeding, if someone has heart attack, then they should be going to emergency ward, no matter what LLM tells to go to, right? So if so this is where the reliability comes in. So I'm saying that these are emergency keywords like chest pain, can't breathe, unconscious, severe bleeding, heart attack. If anyone says something like that, then please go to emergency ward directly. Okay. And there are some crisis keywords as well. Like if someone says suicide, kill myself, self harm, want to die, then these are crisis keywords. Immediately send them to mental health ward. So whatever, like if even if LLM hallucinates, my system is there in place to check for these emergency keywords. Okay. So I will make a router node. The router node, what it will do is it will take in the state again from above. Okay. It takes in the state. The state has all the information. It has name, age, query. And I am making all of the query lower. Why I'm making lower query is because someone can type in query as, okay, someone can type in like chest pain. Okay. And someone can type like chest pain, and someone can type like chest pain. Okay, so chest pain can be typed like in 3 different ways, but I need it to match my emergency keyword. So I'm making everything lower. Okay, so I'm making the query lower so that I can always match. So everything that will be the input in this will be lowercase so that I can match them properly. Now here I am matching if any keyword in query lower for keyword in crisis keyword. So if I have a keyword in query lower, uh, like crisis keyword, then word reasoning equal to mental health. So if it is in crisis keyword, then mental health ward should be selected. If it is in emergency keyword, then ward will be emergency. Okay. So I am making a hard stop here that if someone says suicide anywhere in their key in their message, then please send them to mental health ward. And if somebody says chest pain, then please send them to emergency ward. Okay. Else you invoke the large language model. Else AI needs to be invoked. So response is invoke the large language model. System message is the system prompt, and human message is the content, which is age and symptoms. Okay. I am not sending the name here because name data is not required. Okay. So name data is not required to be sent to a third party, which is a large language model. So I am not sending the name of the person because it's a sensitive data. So human message is age, what is the age of the person and what are the symptoms. And I am taking all of this response as raw response in lowercase. Okay. And now I'm comparing if emergency is in raw, if LLM says that it is emergency, then what should be emergency. If mental health is in raw or mental health in raw, anyway the LLM says, then what should be mental health. If general is in raw, then what should be general, else what should be general, which is safe default. Okay. So I am matching in the LLM output. So the LLM will give whatever response LLM will give here. It can only respond in 3 words, which is emergency, mental health, and general. And I am making ward, which is my state here, ward, as emergency if it is emergency from the output of LLM. If it is mental health from the output of LLM, my ward will be mental health. And if it is general from the output of LLM, my ward will be general. Otherwise, the ward will be general for any general query. Okay. And reasoning I'm giving is that LLM classified based on whatever query was given. Okay. And I'm returning that state. I'm returning the state. I'm putting in word and reasoning in this data. So my state, word, and reasoning will be now updated. So I will have name, age, query, word, reasoning, everything there in the state. Okay. So I made the router node. After making the router node, I will define the words. Okay. Sorry. Define the words. So now here you can become more creative. I'm not defining the words too much here. I'm just printing the word name. Here, whatever happens in that word, you can define that whatever the process of that word is. Maybe for a general word, you need to fill some other form, or maybe whatever that you need to do in that word. Here, what I'm doing is I'm just printing the name of those words. Okay. So whatever process happens after classification, you need to put that process here. I am just putting in name of that of those words. So I'm giving that code again to Nandini so that she can access the code. Okay. So you are defining the words, the general word node, which is I'm just printing general word. You can define the node here properly. Whatever happens inside that, whatever happens inside emergency node, whatever happens inside mental health node. Okay. So once I define the words, I will then define the doctor availability node. Okay. So we'll code up the doctor availability node. So what happens here is in doctor availability node, I'm checking if the doctor is available or not. Okay. So I'm again giving the code to Nandini to paste it there. So it says define doctor availability. It takes in node state, patient state, whatever the state is. I'm taking word from the state and I'm seeing available doctors from doctor's data frame. Okay. So doctor's data frame, which I got from here. Okay. If the status is active, okay, here I need to change one thing. You will also need to change this. If the status is active and not free, okay, so if the status is active, then these are the available doctors. So you take in from ward, whatever ward that is classified. So let's say if a person is classified into general ward, so go to general ward in this table and check if the status is active or not. Okay, so check if the status is active. If the status is active, then take in the doctor name. Okay, if not available dot empty, if um, if not available dot empty, then if it is not empty, that means that if you are getting one doctor, then take in the doctor name and assign the doctor and then mark the doctor busy. Okay, so whoever is active in this, take in the doctor name, mark that doctor busy because you assigned a doctor, and you say that assigned doctor is doctor assigned. Okay, so you print the doctor assigned and you also return the doctor back to the state. So in your state here, you also have the assigned doctor now. So what you are doing is you are checking which ward the patient has to go, and in that ward you are checking which doctor is active. If the doctor is active, you allocate that doctor and you make that doctor busy now. And you say if there is no doctor active, then you say that no doctor is free, patient will be queued. Okay, sorry. And then you print that. All right, so we have also defined a doctor availability node. Now what we need to do is we need to define the graph, which is the most important part of this. And I will explain this little slow. Build graph. Okay, so to build the graph, you need to add this code. I am pasting the code to Nandini as well. So you import state graph and end from langgraph, and you define root decision, which is state which takes in patient state, and it has taking three states, which is general, emergency, and mental health. So you have to make this root decision to only three states: general, emergency, and mental health, and it returns the state ward. Okay. Now you make a state graph. So state graph is which takes in a state, maintains that state throughout all the nodes. Okay, so we define this state here above. So it takes a state memory and it maintains all of this state throughout its code. Okay, so that's what a state graph is. So I'm making a class of state graph, which I will call as a builder class. It takes in the patient state and I add my first node. So I add my first node. So builder.add node, which I name as intake. So this is the name of the node. And which will it point to? It will point to the intake node. Okay, so I'm building the graph, right? So I have this graph here. So in this graph, the start node is the intake node. So I make add first node, which is intake, and this refers to the intake node function, which is here, right? So my first function, which is the intake node, it will be my first node of this graph. So what happens is that whenever I run this graph, first it will ask me my name and age and query. Then it goes to router. So I add one more node, which is the router node, because the router node needs to be there. So I add the router node, which points to router node function, which is here, right? So I have a router node function here, which routes to different nodes, which is a LLM. Then I add in more nodes like the general node, emergency node, and mental health node, which I defined here, the general node, emergency, and mental health. And then I add the node doctor check node, which is my last node. Okay, so I added intake node, router node, emergency, general, mental health, and doctor check by using this add node function. So I made a graph, which is builder graph. I add a add node function and I take in all of these nodes. So first is the node name and second is the function that I will use. So intake router will take in router node function, general will take in general ward node function, emergency will use emergency ward node function, mental health will use mental health ward node function, and doctor check will take doctor availability node function. Okay. Now I set the entry point. Entry point is where my graph will start, right? So graph will start at the intake node. So my entry point is the intake node and I add an edge. So from intake node, there is an edge to the router node. Okay, so I add an edge from intake node to router node. Now after router, I don't have a single edge, right? So I have three different edges here. So this is a conditional edge. This will only be selected based on the router output. Okay, so if the router decision is general, if it says that, okay, I have to go to general ward, then general should be taken. Okay, if it is an emergency, if my router decision is here, whatever ward that it has to go to is emergency, then go to emergency ward. If it is mental health, then go to mental health ward. So it will select which path to go, right? Depending on what is the output of this ward. So whatever the ward that the AI will decide, it will route its decision from to that node. Okay, so to emergency node, to general node, or mental health node. So first is the node, first is the uh, ward name, and second is the node name. Okay, don't to be confused here because both of them look similar here, but ward name and then this is the node name. Now I will add one more edge from general node to doctor check node. I will add one more edge from mental health to doctor check node and emergency to doctor check node, right? So this is what I added a edge from general to doctor check, added one more edge from emergency to doctor check, added one more edge from mental health to doctor check, and finally from doctor check I have one more edge which is to end. Okay, so whatever I was building in NA10 with drag and drop, I am building here with code. I started my trigger node, which is my intake node, which I call as start node, which I put it here, builder dot start set entry node. First of all, I made all of the nodes, add node, intake node, router node, general node, emergency node, mental health node, doctor check node. I set a entry point, which is the intake node. I added edge from intake to router. From router, it's a conditional edge because I have to make a decision based on the condition. If it is emergency, go to emergency node. If it is general, go to general node. If it is mental health, go to mental health node. From emergency, I go to doctor check. From general, I go to doctor check. From mental health, I go to doctor check. And from doctor check, I go to end. Okay, this is what I have made here. And finally, we will use the compile class to compile this graph. So once I run this, all of this graph will run. Okay, intake node is not defined. Intake node is defined, but I have not run this. Okay, run this. I'll run the router node as well. And I'll build the graph. Okay, so graph will be built. After building the graph, I will print the graph. Print graph. Okay, to print the graph, there are only two lines. Okay, from IPython.display, import image and display the graph. So if I run this, it will show what my graph looks like, right? So intake to router node to emergency, general, and mental health, which is a conditional edge. And then there is the doctor check and end. So I can also see the graph which I need to run, right? Okay, after that, there will be only is where I will invoke the graph and give the code for both of them. Invoke graph. That means that I run the graph and I run it like this. Okay, so if I invoke the graph, it will ask me my patient name. So if I'm telling that my patient name is Amit, okay, it will now ask me the age. It is 32, and I will describe my symptom is I have fever and cough. Okay, I'm making some mistake here. So that FEVER and coughs. Okay, so if I type in I have fever and coughs, so it will send me to general ward. So it says that LLM classified based on I have fever and cough. Doctor assigned Dr. Sharma. Why? Because Dr. Sharma was free. Patient is Amit and ward name is general and doctor assigned Dr. Sharma. So it will assign me a particular doctor based on whatever problem that I am facing. Okay. And if you print the table again, sorry, you will see that now Dr. Sharma would be busy. Okay. So if I print it again, Doctor's DF, then you will see that now Dr. Sharma is busy because it has classified that here, right? So because it is assigned to me right now, so it is busy. All right, so I'm giving the final codes to you. A building graph I had given, just the print graph part. And the final is the invoke. Okay. All right, so Nandini will share with you the final two codes, which is to print the graph and to invoke the graph. All right, so this is the whole flow, not too much lines of code. It is just 50 to 60 lines of code, and a very, very powerful agent has been designed with this. If I use this in a real case, I will not use a CSV file, but I will use a database from somewhere. So let's say that I will use a Superbase or MongoDB, whatever database. I'll be able to use that, import the database here, and I will use that database, which is live database, in order to use this agentic AI framework. Okay. Now, after designing this, once you are completing this, you can check it. You can use check it for different cases. So let's say that I will um, okay, patient name is Niyar, and it will ask me the age again, which is 33, let's say. And if I say that I have high fever, then it will classify me as emergency, because for high fever there can be like emergency situation, right? So right now it's going to emergency ward because of the high fever, and doctor assigned is Dr. Khan. And if I run this, then it will show that Dr. Khan is also busy now, right? So, and if I say that there is another patient, so let's say whatever the name is, 32, and I am not able to think clearly. Okay, so it is giving me to go to mental health ward because I'm not able to think clearly, which is a case of mental health. Dr. Mehta is assigned, and if I look at the doctor's list, Dr. Mehta will be busy at that point of time, right? So now you can make it like more complex. I have just made it simple. I just taught you like how can you make your systems using, like how can you use LLM to make a Lang graph. Now, what you will do now is you will not use Colab, you will use something like VS Code, and you can use any of the AI tools that you want to use to make your agents. What I expect from you is you make a hospital agent, a front end and a back end of that agent, and so you have back end and a front end of that agent, and then you host this front end and back end somewhere, which I'm going to show you how to do that. If you want to do it with AI, then you can use any AI. I use Claude Code for this. So I use a new session. So you copy your code from the Google Colab file, and you come here in VS Code or any AI tool that you use, Cursor, Anti-Gravity, whatever you use. You can ask AI to create a very nice backend and front end for this agent. And then if I ask it to run this, then it will run this agent for me. Okay. So it has fast API. It is using LangGraphs. So you have like front end and back end. You ask it to create a very beautiful front end and back end for you. And here I am running this up. Okay, I'll provide the key. So I go to backend and I go to the app and .env. So it has given me example. I am going to make it env, make env. Okay, so here I will paste in my grok key, for which I will stop share for some time, and I will paste in my grok key. Okay, so I pasted my grok key in here, and I'm now sharing. Okay, so it will retain the grok API key, and it will run my agent now. Okay, it has created me a backend in Python, a front end in Node and React JS, which I will deploy on Vercel, and backend I will deploy on Render. So you will also need to make something like this if you want to host it up. So you make a front end and backend. You take a code from Google Colab if you want to design it on Colab. If you want to design it entirely on AI, you can also design it entirely on AI. So you need to make sure that you are designing a backend and front end for this. Backend you will host it on Render, and front end you will host it on Vercel. And okay, already there in .env file. And it will start my backend server. So my backend server can be started by a Unicon uh, server. So it is taking in my Grok API key. So it is starting my fast API server, and it is checking my server health, which is on port 8000, and it will now take in. Okay, so it already is port 8000 occupied. So it is making another port, which is 8021, which is running the server. And now it will open my front end for me. And I will show you what I have designed. So it will just run this here. Okay, it's invalid API key. All right, maybe I use the right key though. Okay, it's taking in my API key and running it up. It's a valid API key. It's starting it up, checking the health. Health is okay. Posting the status. Backend is running successfully. Now start the front end. Start the front end. And it will run the npm run dev command, which I can also run from like, but I want it to run it for me. So like I'm just giving you a demo of how you can purely wipe code it as well. But you need to also understand what it is doing. So right now I am also reading what it is doing, right? It is running the npm run dev command, which is giving me a portal to run this command. And where is it? Okay, so it will run on localhost 5174. So I can go here and I can see my hospital agent running. Okay. So I can go it like this, and I can copy it from here and continue it in the browser. So I run it in my browser, and I can see that my kiosk is here, right? So now I can put in my information like Amit Tiwari and my age. Now you can beautify it. I have not beautified it yet. 32. And what's bothering you today? I am having high fever. Okay, so if I check in, so it assigned me to a doctor called Dr. Khan. Your appointment. Thank you, Amit Tiwari. AI tried as the symptom described. So it goes to the emergency ward, and my appointment is at 8:30 a.m. Done. Next patient. So let's say that I have one more patient, which is Clara, and the patient age is 27, and patient is I am experiencing cough. Okay. And I check in, it's routing, and it says that it goes to general ward, and the doctor assigned is Dr. Iyer, and appointment time is 9:15 a.m. Okay, done. Next patient, let's say it's Arav, age is 21, and it's having accident. Okay. And I check in, it goes to emergency ward. It says, thank you, Arav. You're uh, classified as doctor is Dr. Rao. Appointment is 8:30 a.m. Next patient. So I have both of the doctors booked now. So I will just take in one more time. Um, Amit and 33, and it is having chest pain. All right. So if I check in, then it says that my Dr. Khan's appointment is 8:40 a.m. Why? Because a 20-minute wait time. So it showed me 8:20 right now. So it is Dr. Khan is now busy with some other person. Now my other appointment would be at 8:40 a.m. All right. So you have to make something like this. Now, how to host this up? I'm sorry, I'm not taking queries right now. Why? Because I'm also teaching you how to deploy this. So if you want to host this up, you need to make the backend and front end, and you need to deploy this to Git. Okay. So you can ask the AI to deploy this to Git as well, push to Git, and it will be giving you commands to push to Git. From here, you can also use MCP directly for from here to push to Git. Right, so it's making a Git ignore and everything so that it ignores the environment files and all. So it will just push this to Git. Okay, so it is writing git ignore because I don't want the .env file in my backend, because I don't want in my git anywhere my API keys to be exposed. Okay, although I already exposed this, maybe I will delete this one now. So it will check for the git status. There is on branch main, there are no commits, so it will make me an initial commit and it will just commit this up. Okay. So you need to make a git repository and you commit this up. So it will commit and it will insert everything committed on main. And where do I need to do? So it can also create a GitHub repo for you. So I submit this. So it will create a GitHub repo, and okay, I don't have a GitHub CLI on this, so I will create the repo manually. So I'll go to my GitHub and from the GitHub, I create the repo. Okay. So github.com, and I sign in to my GitHub. I'm sure that you might have a GitHub account. If you don't have a GitHub account, you will have to make one. Make a new repo in GitHub. So I'm saying this is hospital agent. Okay, and I create this. Okay, and I give the information of this to VS Code, and then it will know that I have created this. Okay, so now initialize to the agent will push. Okay, so I create a new GitHub repo, and from here it will commit and push to that repo. Okay. Okay, I'm reading the messages now for the queries, but right now I'm just put to main that I can can show the deployment as well. But meanwhile, I'm also reading. Okay, so I'm using VS Code. For those who are asking me for the app, it is asking me my keychain password, which I'll stop share and now get it from my password. Just give me some more time. Okay, GitHub password. I need to paste in the keychain. Which is this. And I'm done. Okay. So, okay, so my commit is pushed, and if I refresh it here, I will have my backend and front end both here on my GitHub. Okay, so I have created a GitHub repo of Hospital Agent, and I have my backend and front end both here. So I will deploy this now. If I want to keep it live for everyone to use, so deploying the front end on Vercel is a good practice. So I am going to Vercel. So Vercel is like easy. Whatever you deploy on Git, if you change anything on Git, it will automatically be changed on what Vercel as well. So we'll make our front end in Vercel. So if I continue with Google and continue with email. Okay, so it's not a valid name. So maybe I will use my company's Vercel account and I create another agent, which is a project. So Vercel helps you like build free sites for 30 days. I guess it has a trial period of 30 days. So you create a new project and create a add new project and okay, I'm importing. So it will give you, if it will ask you where to import your project from. So I'm importing this Git repo, which is Hospital Agent. So I already have connected my GitHub with Vercel. So I'm asking it to just the front end part, not the back end one. So I select the front end and I deploy. So if I deploy this up, I will have my front end on Vercel. Okay, so it will build everything up. And because I have asked the AI to design it in a way that I'm deploying it to Vercel, so it will be deployed. And you will see that I have my app running on this address now. Okay, so now I need to, so this is just the front end, right? So this, it doesn't have any back end because my back end is in Python. So I will have to host my back end in render. So I go to render and you click account in render, you go to dashboard. You can also use Railways to do. There are different things that you can um, deploy it to. I go to my dashboard and there I will create a new project similar to how I did it in Vercel. So this is, just look at it right now. No need to kind of like follow me because this will take some time. So deploy your project on Git, go to Vercel, deploy it on Vercel. If you have a front end, for the back end, you need to deploy it on Render. So I am using my GitHub account to sign into Render so that I can deploy it there as well. Now to deploy it on Render, I will have to also create the env files, which I will also show how to create one. So it's not enabling me. Okay. So yeah, password, sign in. Not for login. Maybe I will just log in with Google. All right. Have to go to my phone. Okay. All right. My workspace is suspended because I have not paid my invoice. So maybe I will have to pay the invoice first. Like, okay. So I cannot do on this one. Maybe I can do on. So it's fairly easy. It's similar to what Vercel is. And you just need to check one thing is the course issue. So course is like cross origin resource sharing. How are you going to tell their front end that you are going to fetch the information from the back end? So that URL you will have to put in your in your code, right? So if you see here in your front end, wherever, so this is the API URL. You will have to put in your URL here, and you will have to tell that you are fetching the data from the render, right, and not like from this localhost. So right now I have deployed it here. So instead of this, your render link will come. So this is for like localhost because this is where my backend is running. So what you need to do is just replace this in your Vercel where you have deployed it with your render uh, link. That's all what you need to do. So if I kind of like use Google to log into render and I have a project here, if I add in a new project, which is my web service, so I'll add a web service and I go to GitHub and I add my GitHub here. Yeah, it's already there. And okay. Yeah, give permissions, repo, which is where it is, hospital agent, right? Select a repo, hospital agent, and I save, and it will take me to render. So in render, what I will do is I will deploy this now. Already selected this one. Uh, hospital agent, I already selected. Okay, not reading this. I gave permission, but yeah, I gave permission to read this. It's not reading. Something is not working. Maybe I can also do it from a public Git repo because this is public. So I copy, paste it here, connect this up. And yeah, I select a project, which is my project. Environment is production, hospital agent. I install using the requirements. I use the free version from here. Root directory will be backend. And once I add in a variable, so I will add in a env file variable here, which is my env, right? So in my backend, I will have an env. So I add in the grok API key, go to render, add in the variable and the value of my API key here, right? So let's say that this one, which I will delete later on. So I add in a, if I deploy this up, and here it will be UVCon. Yeah, give me, I'll ask the AI to generate this one. Okay, so I copy this up, go back to Claude, ask it to generate the code for me. I used to remember this, but I forgot. I have not used it for too many times now. Generate the code. So it used to be UECon run. I forgot it. So it will type in, yeah, this one. Okay. And if I deploy this up, so this will deploy, this will give me a URL where it will be deployed. So it's building it up and it will deploy here. And my backend is now this. Okay, so if I copy this link from here, I go back to my Vercel, which is here, and uh, in my project, what I need to do is I will go to dashboard, and here I will add in a environment variable, which is from here, environment variable, and I add a new environment variable, which is the value will be this, and the environment variable will be from here, white API URL. Okay, so this URL to my render account. Okay, so if I save this, now I have the white API URL, which will be the render account. All right, so this instance, so it is rendering, and once it renders, it will give me um, a status, which is the health of this app. And what I need to do is I just need to go to Vercel, and where is it? And there I will just change the environment variable, which I have done. So here, if I say like Amit 32 and fever, right now it will not be routing me up because my it's saying fail to fetch because my render is not working. So once I have my render working here, once I have this working, then your app is almost live. Once it is live, then I will have my agent uh, ready. Okay, so till now, I will just wait and I will type in fever. And if I click on check-in, then it will go to my render again, but my render is still spinning. Um, so once it spins, once it is ready, I will have my app ready to work. All right. So this is like the final thing that you have to create. Everything like deployment, you have to create a front end, you have to push it to GitHub, you have to go to Vercel and deploy the front end there, deploy the back end in render if you want to, and then create a whole wholesome agent like this. All right, so now I will take in your queries. I'm using VS Code with Claude. Okay, so yeah, so we have extension of Claude in VS Code. You can use it from there. I explain backend and frontend part. So backend part will be in Python and frontend will be in React and White. So you can use, you can ask the AI to create it for you. So you cannot build a complete front-end and back-end on Colab. No, you can't. So Colab is generally used for Python. Can't we create projects and do coding for job interviews? Yeah, you can create projects, but coding. I think is getting obsolete. Nobody is coding, even in kind of like big companies. AI assisted coding is what you need. Okay. Git push is enough. Yes, you just need to deploy it on render and Vercel, and then you just push it to Git, and then you can deploy it anywhere. So once you push it to Git, your changes will be deployed to render. Um, we didn't make how the doctors will receive info, right? So you need to make it. So I am not making it here. So you need to make it how they will receive the info. So you can add in like sending the data through an email or a WhatsApp, whatever. But for that, you will need to use the API from WhatsApp and Google, which is I will not be able to cover in this class. Yeah, you can use this method to create your project. You can choose any problem statement. How can we do this on VS Code? So on VS Code, what you need to do is you need to copy
Dear students, sir might be facing some network issue. Till then, I request you all to hold on. Okay, so by the time sir joins, I just have certain questions for you. Did you enjoy today's session? I know this is a bit overwhelming for you to cover a lot of stuff at a very short time, but again, I request you all to watch the recording, take notes out of it, and this would be really, really helpful in your future. If you come across any hackathon, you can showcase this project to them because you are building something related to SDGs, right? So I'm damn sure the evaluators who would be evaluating your projects would be really impressed. So yeah, by the time Sir joins, can we all have a fun activity? Okay, so I will be asking certain riddles, okay, and the answer of these riddles would be obviously technical terms. I won't be asking something out of syllabus. I would be asking certain question, and the answer would be something technically. Now, I request you all not to use Chat GPT or any other AI platform. Use the neural network that is in your brain, not in the system. So, first riddle is I don't have a brain, but I can think. I don't have eyes, but I can see. I learn from you every day. What am I? Great. AI LLM. CPU? No. Okay, next question is I am built on many layers just like a cake. I turn words into meaning. Next question. No, not neural network, not LLM. I repeat the question again. पहले ध्यान से question सुनो. I I am built on multiple layers, on many layers, just like a cake. I turn words into meaning, not NLP, not AI agent, not Docker container, not CPU, not OS. Okay, I'll give you a hint. The answer is answer में a movie was made, not cybersecurity, not translator, but great transformer. Who was that? Okay, Rishabh Dinam. One last final question before I show the attendance QR to you. I am the future of work and play. I help you automate and stay. Human plus me is equal to better way. I repeat again. I am the future of work and play. I help you automate and stay. It's not AI. Human plus me is equal to better way. Not N8N, not robots, not rag, not attendance. Okay, so yes, this is AI agent. So great students. Thank you for putting your brain into these riddles and coming up with great responses. So now it's time for something that you all are waiting for a very long time. So I will showcase the attendance to you all. Scan this QR, mark your attendance, and these days it was super fun, excited, and we were very glad to see you all enthusiastically attending all the master classes. We are almost 80% done now. The game is in your hands. You have to build up a project, you have to come up something really futuristic that fascinates me, Amit sir, and all of us. On 15th of July we have World Youth Skills Day. So we have given some skills into you, and we hope to see you all build amazing projects. If possible, build such projects, post about it in LinkedIn, tag Amit sir, tag me. If you can't find my account, you just search for my name, that is Nandini Sudalaimani. In LinkedIn you will find it, and we would be really happy to see all the fascinating projects that you have made. I repeat again before you leave, make sure you complete your attendance using the QR code on the attendance link shared in the chat as well. Remember, your attendance is very important for your internship records and certification eligibility. And I urge all of you to complete your LP. If you haven't completed it yet, we would be probably sending a report about your performance to your TPOs, to your college coordinates. So I request you all to take this internship seriously and complete all the deliverables that is assigned to you. And lastly, although this is our last masterclass, the journey is not over yet. We still have the question and answer session that is being scheduled for tomorrow. I know that we have resolved almost 98% of your queries with respect to offer letter and dashboard. Additionally, if you have any other queries, you can join tomorrow's session that is scheduled at 4 o'clock. We will be sharing the link in the group. We will be addressing all your internship related queries and non technical queries. Okay. On behalf of IBM Skills Bill, AICTE, and BharatCares CSR Box Group, thank you all for being such an enthusiastic learners throughout this internship. We wish you all the best for your projects and your future in AI. See some of you all in the upcoming question and answer session. Have a wonderful day and happy learning. Just a important announcement from Amit sir. Try out your project. If you're not able to complete it or deploy it, we can schedule another masterclass for you. So this thing we are giving into your hands. You try it out. If you're not able to follow it, please reach out to us. We are always happy and open to host another masterclass. We can have one more masterclass for project question and answers. In that masterclass you can ask all your technical related queries. We will be always there to assist you. Okay, fine. See you all, guys. Thank you for joining all the master classes.